Hi everyone. Today we're here to talk about Trippy, an LLM-powered travel planner. Travel planning is a time-consuming challenge, despite numerous existing platforms like Expedia and TripAdvisor. Current solutions are quite costly, require extensive manual effort, or often fall short in addressing specific needs. Consider Sarah, who needs to apply for a European visa and requires a detailed, documented itinerary. Then there's Michael, whose abstract desire to go on a vacation filled with viewing stunning sceneries requires extensive research to translate into actionable travel plans. These distinct scenarios highlight the need for a more versatile and intelligent travel planning method. Our solution is an AI travel planner called Trippy that combines large language models with Google Maps API and route optimization. By providing basic parameters like destination, dates, and trip type, users receive personalized, optimized itineraries. Through advanced techniques like fine-tuning and RAG, we eliminate manual planning while ensuring practical, efficient travel recommendations that cater to diverse user needs.
Okay, so going over our technical architecture, starting on the left with our application containers, we have containers for the data creator, fine tuner, API service, front end, LLM RAG, and data version. We are packaging these into Docker images that are pushed to a registry. Going to the right side, we can see that Kubernetes is used for orchestration. In the Kubernetes cluster, we include a Nginx container that acts as a reverse proxy which handles routing for the API service container that exposes the application's backend functionality, and the React-based frontend container that serves the user interface. In terms of internal ports, the front-end service listens on port 3000, the API service listens on port 9000, and ChromaDB listens on port 8000. Also, Nginx Ingress controller listens on ports 80 and 443 for incoming traffic. And so we are actually using a lot of Google Cloud Platform features for most of the underlying infrastructure to support deployment. Vertex AI is used to handle the data creation, model training, and model deployment. The fine-tuning text data is stored in a Google Cloud storage bucket. And finally, we are using Google's Kubernetes engine cluster.
I'd like to show you a demo of Trippy, a travel planning application running on a Kubernetes cluster. We can access the website through this link. And what we see right now is Trippy's front end. It has an user-friendly and intuitive design. Simply tell Trippy three pieces of information. So first is your desired travel destination. And for this demo, let's try New York City. And for second is type of trip. It could be friends, family, or simply arts and museums. And third is travel dates. And for this demo, let's select December 15th to 17th for a 2-day trip. And then simply click Plan My Trip, and Trippy will generate results in seconds. So the result page features an interactive layout. On the top left is Google Map visualization, displays each day's planned locations. And on the right-hand side is an interactive board, allows you to choose which day to visualize. For this demo focused on arts and museums, you will see locations tailored to that theme. And down below is a detailed itinerary summary that provides city information, a day-by-day breakdown of your plan, and helpful tips for your December trip to New York City.
Okay, so for the challenge, some are solved and some are planted for future updates. First, we found our location extraction might still fail, so we implemented mechanism to automatically reprompt the LLM upon detecting failed attempts, improving the overall application stability. Also, we are facing the limitation of our GL coding API, which currently restricts us to 50 queries per second. We are exploring higher capacity alternatives and negotiate better terms to expect our capabilities. Additionally, we will implement caching for frequently accessed data, significantly boosting our system efficiency. We also recognize the needs for better chat history management. We are developing a new feature that will save the user sessions and allow the travelers to download the PDF format, making the travel planning more convenient and reliable. We are enhancing our route optimization by integrating the real-time traffic data, ensuring each journey is as efficiency as possible. Also, users can customize their trip more freely and can input their starting point in the future. Yeah, that's it. Thank you. Thank you for your attention.